In this video, we're going to take a look at the Chapter 3 practice test for our intermediate algebra course. The first question on this exam, now Chapter 3 is about system of equations. It also has word problems, and it also has inequalities, system of inequalities. So our first several questions are going to involve system of equations. So this problem says, solve the system of functions by graphing, then classify each system. So we have two equations here, and the function notation is really a little bit unnecessary. They introduced function notation in chapter 2, and then they feel like they need to shoehorn it in wherever they can find a spot. But really, these are just y variables. So let's just think of these two equations as y. Okay, let me try that again. Let's see, what am I doing? Okay. Y, okay, I wasn't sure if I was going to write. Y equals x minus 1, and y equals negative 3x plus 7. So there are several techniques you can use to solve a system of equations. The one they're asking us to apply here is the technique of graphing. So the solution to this system occurs where these two graphs cross one another. These two equations are linear equations, so we're going to get two lines, and where the two lines cross will be the solution to the system of equations. So let's graph this first equation in blue. And so you have to think back to chapter 2. How do we graph a line? We use the y-intercept here, which is 0, negative 1. And we use the slope, which is in front of x, which is a 1. And so we will start by plotting the point 0, negative 1, which is about right here. The slope being 1, think of that as 1 over 1. We're going to go up 1 to the right 1. Up 1 to the right 1. We end up right here. And so that gives me 2 points, and from that I can graph my line. And what's important about this is that you have to make sure the graphs are accurate. So 2 points is all you're going to need on Math Excel. And if you have a ruler and you're doing it on paper, 2 points should be fine as long as you make that line straight. But since I'm doing it on this computer here, I'm afraid I'm going to go off track here. So I'm going to keep going up 1 to the right 1, up 1 to the right 1. And get several points just to make sure my line goes the way it's supposed to go. Because if I'm off the mark, then I won't find the solution that I'm supposed to find, right? And also, I don't think it's going to matter as much back this way, but let's do the same thing this way. Down 1 to the left 1, down 1 to the left 1. All right, and so I'll connect these points with a straight line. See if I can do that with the points being here a little bit off. All right, and to back this way, same thing, to the left and to the right. All right, so that's my first equation. We'll do the second equation in green so that we can distinguish between the two equations. Here the y-intercept is 0, 7, and the slope is negative 3, so we'll think of that as negative 3 over 1. Sorry, it's supposed to be a 3 right here. And so we're going to start at 0, 7, which is right here. And we're going to go down 3 and to the right 1. So down 3 is going to take me down to 4. To the right 1 would be right here. And I want to make sure it hits this other line exactly in the right spot, so I'm going to do it again. Down 3 to the right 1, and it actually lands directly on this point that we already have on this other line. And so there is my second line. It should go something like this, okay, and also up this way, if I can get it going. Okay, and so where the two lines cross one another is where we find the solution to our system of equations. So this point right here, which is at 2, 1. Right, x is 2, y is 1. That is where the two lines cross. That will be the solution to my system of equations. So this is what you want to type in to this box right here. If you want to be sure that, especially if you're doing it by hand, you might want to double check to make sure that this actually is where they intersect each other by checking it in the two equations. So if we plug in 1 for y, 2 for x, make sure it matches up. Here we get 2 minus 1, which is 1. And on the left-hand side, plugging in 1 for y, we get 1, so that checks out. Do the same thing here. We'll plug in 1 for y, 2 for x. Negative 3 times 2 is negative 6. Negative 6 plus 7 is also 1, so again, that checks out. So it works in both equations, so that is the solution to the system. Now, if you get a system that has a solution, 1 or 2 or 5 or 100 or an infinite number of solutions, it's consistent, right? So if your system has any solutions whatsoever, it's a consistent system. The only time it's inconsistent is if there's no solution at all. Right, that's the only time you would select inconsistent. We have a solution this time, so our answer here is that it's consistent. to decide whether it's independent or dependent, if it has an infinite number of solutions, it's dependent. So if it's infinite number of solutions, then we would select dependent. We did not get an infinite number of solutions here. We only got one, and so it's independent. So this is a consistent, independent system of equations. All right, let's take a look at the next one. So here we're being asked to do the same thing, graph both of these, and then find the solution to the system based on the graph. This time the graphs are multiple choice. So to graph this, we could almost do x and y intercepts. The one where that doesn't quite work is the bottom one here, because the y-intercept is not going to work out to be very nice. However, even if it's not that nice, we could still probably estimate it using the graphs over here, using the multiple choice. So if we were being asked to actually graph it directly on Math Excel, fractions are not going to work because Math Excel won't accept fractions. But since this is multiple choice, we can get away with having some fractions. We can still figure out which graph is correct. So let's do that. We're going to do x and y intercepts here. So we have 3x minus 9y equals 45. So to graph this, instead of doing the slope, I'm just going to use the x and y intercept. So the x-intercept is going to be, we plug in 0 for y, and then we solve for x. So we're going to get 3x minus 9 times 0 equals 45. That's just going to be 3x equals 45, because that's just going to be 0, so it goes away. Divide by 3 on both sides, and we get x is equal to 15. Kind of a big number, so that actually doesn't fit in the graph window here, but we'll see what we could do with that. Hopefully we can make that work. So we get 15 comma 0. The y-intercept is going to be, you plug in 0 for x. So we're going to get 3 times 0 minus 9y equals 45. Get negative 9y equals 45. Divide by negative 9 on both sides, and you get y is equal to negative 5. That one we could definitely use, right? So this just goes to 0. That's why that disappeared. And so we're going to get 0 comma negative 5 as our y-intercept. All right, so if you plot both of these points, let's look at our multiple choice options here. So this graph looks like it has the point 0 comma negative 5. And it looks like the y-intercept would eventually be around 15, right, if the graph kept going. So B is still definitely within the realm of possibility. D is not, right? No graph here in choice D, no, I shouldn't say no graph, no line in this graph has a y-intercept of negative 5. Notice it doesn't cross that point here. So D cannot be the right answer. There's no way that could work. C could still be correct because we have this graph here. We have this line with a y-intercept of negative 5. And again, this line looks like if it kept going, it probably would cross at about 15. This one cannot be correct because neither one of these lines has a y-intercept of negative 5. And so A can't work either. All right, so we're down to B and C as our two possibilities. What's going on with B is that you're getting the same graph twice. So if we go to the second equation and we get the same x and y intercepts, then that means B is the correct answer because we're getting the same graph both times. We're getting just one line from both equations. If we get a new set of x and y intercepts that's different from the first set, then C would have to be the correct choice. And I'm sorry, I should have put a box around this. All right, so let's look at the second equation. We have 2x minus 6y is equal to negative 4. Let's do the x-intercept first. We're going to plug in 0 for y, so we get 2x minus 6 times 0 equals negative 4. That gives me 2x equals negative 4 because this just goes to 0. This just equals 0 and just disappears from our equation. Divide by 2 on both sides, and we get x is equal to negative 2. All right, so we get negative 2. Let's try that again. Negative 2 comma 0. So that is my x-intercept. And then the y-intercept, I'm running out of room. I guess I'll do it up here. We'll do the y-intercept up here. You're going to plug in 0 for x. So you get 2 times 0 minus 6y equals negative 4. That goes away because it's just 0. So we get negative 6y is equal to negative 4. And so y is going to equal negative 4 over negative 6, which reduces to 2/3, right? And so we're going to get 0 comma positive 2/3, which, like I said, I could see that happening ahead of time. And normally you don't want to have to graph points that have fractions. And on Math Excel, it normally won't even let you graph points with fractions. But since this is multiple choice, we can work with that. So 0, 2/3. The important thing is that these two are different than the two we got from the first equation, which means we're going to get a different line, which means C has to be the right answer. It's the only one of our choices left that has two different distinct lines. But let's just double check to make sure these points are actually showing up on this line. So we have -2, 0, which is right here, and we have 0, 2/3, which this looks like it's in the neighborhood of that. And like I said, for the first equation, we got 0, -5, which is right here. And then we have 15, 0, and it's a little bit off of our graph, but it looks like it's heading in that direction, and it will cross there. So C is the correct choice. Another way you might figure out the correct graph would be to solve each one for y, and then look at the slopes, and you'll see that the slopes are the same, which means the lines have to be parallel. So it's either going to be A or C, and then by looking at the y-intercepts, you'd figure out that C would have to be the right one. So our conclusion in this case is that there are no solutions to this system of equations because the lines are parallel. They never cross each other, right? So the solution to a system of equations is where the two graphs cross one another. If they never cross one another, there's no solution. If there's no solution, it's an inconsistent system. However, it's not infinite. We don't have an infinite number of solutions. We have none at all. So it's still independent, right? You only choose dependent if there's an infinite number of solutions. This one only has, this one, I shouldn't say only has, this one has no solutions at all. That's definitely not infinite. And so we will still select independent as the type of system for that. Okay, move on to the next one. Sorry, the graphing ones take a little bit of time. These other ones should go a little bit quicker. Here we're being asked to solve the system of equations using the substitution method. So we're not going to graph this time. The substitution method is asking you to take one of the equations and plug it into the other equation. In order for this method to be applicable, we have to solve one of the equations for one of the variables. Or preferably, the problem already has that done for us, which is what's going on here, right? The second equation is already solved for x, right? It's already solved for x. So we're going to plug what x is equal to in the second equation. We're going to plug that into the first equation for x. So we're going to replace this x with what it's equal to from the second equation. So I'm going to have 2y plus x equals 9. But in place of x, I'm plugging in 3y minus 4. Everything else is going to stay the same. So we'll still have 2y here. We'll still have this plus sign here. We'll still have the equals 9. And by doing this, we have both equations present at the same time, right? This is where the x variable was, and so we still have 2y plus x equals 9. But in place of x, we put the 3y minus 4, and so this equation is now aware that x should also equal 3y minus 4. So we have both conditions, both requirements together in one equation. So anything I get out of this equation has to be related to both equations being satisfied at the same time, right? And so I'm going to solve this equation for y by combining like terms. So we'll get 5y minus 4 equals 9. We'll add 4 to both sides. This one doesn't work out very nice. That kind of stinks. Get 13, and then we'll divide by 5 on both sides, and we get a fraction this time. So that's kind of unfortunate. You don't really expect that to happen on the very first version of this problem that you see on the test, but that is what happens. So we get y equals 13/5. That's the y value. But that's not a complete solution. So remember, in the last couple of examples, or at least the first one that we did, the solution is where the two graphs cross one another. It's a point. It has to have an x value and a y value. We only have the y value, so we still need to find the x value. And the way you find that is to take what you found for y and plug it back into either of the two original equations. So since it doesn't matter which one, you'll get the same answer from either one. So since it doesn't matter, we want to choose the one that'll be easier to work with, which will be the bottom equation. It's already solved for x, which is the variable we're looking for. So this will be a little bit easier to work with in this case. So I'm going to take that second equation, x equals 3y minus 4, and in place of y, I'm going to plug in 13/5. So I get x equals 3 times 13/5 minus 4. And then I simplify that, and I'll find my x value. So think of this as 3 over 1. Sorry, I kind of messed that up a little bit. Multiply across. So what we're going to get is x equals 39 over 5, right? 3 times 13 is 39. 1 times 5 is 5. Minus 4, which I will also think of as a fraction, being over 1. And we have to get a common denominator. So the common denominator will be 5. So what we're going to get here is 39 over 5 minus 20 over 5. Right, that's what you should get there. And then subtract these fractions. This is supposed to be a subtraction here. 39 minus 20 would be 19. The common denominator will stay the same. It's going to be 5. Right, and so that would be my x value. When you go to type this in the Math Excel, you need to type it as an ordered pair, which means x goes first and y goes second. So even though I got that number last, it needs to go first in my ordered pair. X is 19 over 5, comma, y, which is 13 over 5. And that is my solution to this system of equations. Right, here we're being asked to do the same thing, solve this system of equations using the substitution method. This one's maybe a little bit too similar, at least starting out, a little bit too similar to the problem that we just did because you're going to do exactly the same thing. The bottom equation is already solved for x, so let's plug that in for x into the top equation. So the top equation, I'm just going to write it out again so you can see how the substitution is working. In place of x, I'm going to plug in 7 minus 4y. All right, that's what the bottom equation tells me to do. The rest of the top equation stays the same, so we're going to still have the plus 4y, and we're still going to have the equals 8. And then we go to solve this by combining like terms, but what happens here that didn't happen last time is that both of our y variables cancel out, right? So we get negative 4y plus 4y, those just cancel each other out, so we only end up with 7 equals 8, which means our variable disappeared on us. So anytime you're trying to solve a system of equations and your variable just up and disappears, you have a special outcome. And it's either going to be no solution or infinitely many solutions. It's going to be one of the two extremes. And the way you decide which one it is by the result you get here. So after the variables cancel themselves out, if what results is false, like it is in this case, 7 does not equal 8, that's false, that means there's no solution. If what you get here is true, that means there's infinitely many solutions. Right? So there's going to be no solution in this case. I think we'll have an example later on where it comes out true, and I'll talk more about that in more detail when we get to that. But for this situation, since it was false, that means there's no solution. So that's what you'd want to select on Math Excel, that there's no solution. All right, let's look at one more substitution method example. What makes this one a little more challenging is that for substitution method to work, you have to have one of the equations solved for one of the variables. And that wasn't done for us this time. So the last two examples, they did that part for us. This time we have to do it for ourselves. What's nice about it is it doesn't matter which variable or which equation you use. So what you want to do is solve for the easiest variable in the easiest equation. And this one's kind of a toss-up to me. I feel like the bottom equation, solving this one for y, looks kind of easy, except there's a negative sign in front of that, which I kind of don't like. The top equation, solving either for x or y here, because all these numbers are even, doesn't seem like a bad idea either. So maybe just to kind of change things up a little bit from the last two examples, I will take the top equation and I will solve it for y, because that seems like that's easy enough to do. So to solve that for y, I will subtract 2x from both sides, subtract 2x, subtract 2x. So I'll have 2y equals negative 4 minus 2x. And then we'll divide by 2 to get y by itself. So we get y is equal to, this 2 divides into both of these terms, so we get negative 4 divided by 2, which is negative 2. And then negative 2x divided by 2. So the 2's will cancel each other out, and I'll just get negative x. So that's from the top equation. So remember which one we used, because now the next step, we want to plug this into the other equation that we haven't used yet. So if you plug this back into the equation you just got it from, you're going to get the wrong conclusion from that. So we're going to plug this into the bottom equation, the one we haven't used yet, and we're going to plug it in for y. So in place of y, we're going to plug in this, negative 2 minus x. So I'll write the equation from scratch just to make it as clear as possible how the substitution's working. In place of y, I'm going to plug in negative 2 minus x. Everything else is going to stay the same, so I'll still have 2x as the first term. I want to subtract everything that follows. I want to subtract everything that y is equal to, and since y is equal to negative 2 minus x, you have two terms there, you really need to use parentheses around that. So you subtract everything that you're plugging in for y, and then the equals 6 will stay the same. So be careful with that negative sign. What's going to happen is you'll have to distribute it to both of these terms. So you get 2x plus 2 plus x equals 6. And it looks like we're going to be getting another fraction here, if I'm not mistaken. So I'll combine like terms. I'll continue up here. So I'll get 3x plus 2 equals 6. And then we'll solve. We'll subtract 2 from both sides. I'll get 3x is equal to 4. And then divide by 3 on both sides. And we'll get x is equal to 4/3. All right, so that's our x value. As I mentioned earlier, the solution to a system of equations has to have two values. You have to have an x value and a y value. So we need to still find the corresponding value for y, and we'll do that by plugging it back into either of the original equations. So I'm going to use the one that will be easier for me to find y from, and I think it'd be this one where I've already solved it for y. So this is related to the original equation, the first one up here. It's already solved for the variable that I'm looking for, so I'm going to plug it into this one right here. So I'll try to see if I can make that fit right here. So we'll have y equals negative 2 minus x. We're going to plug in 4/3 for x. So everything else is going to stay the same, and then we're going to solve for y. We need a common denominator. I say we're going to solve for y. It's already solved for y. We just need to simplify these fractions here. So common denominator, multiply 3 to the top and bottom here, and I'll get y equals negative 6/3 minus 4/3. It's supposed to be a minus sign. And so I'll get y equals negative 10/3. All right. So my final answer would be x, which is 4/3, comma y, which is negative 10/3. Okay, so that's substitution method. There's one other method that is introduced in Chapter 3 for solving a system of equations. It's called the elimination method. The elimination method works by adding the two equations together in such a way that one of the variables is eliminated. That's why it's called the elimination method. And when they're being nice enough about it, it's set up for that to happen automatically. So in this case, if I add these two equations together, the x's will cancel themselves out. So it's just set up to work out like that. So I'm going to take advantage of that and just go ahead and add these two equations together. I don't have to do any work to make anything special happen here. I get x minus x, so the x's cancel out. That's the important part. A variable has to get canceled out when you do this. And then we have 9y plus 8y, which is going to be 17y. And then the right-hand side, we add those together. We get 17 plus 0, which is going to be 17. And these have to be equal to each other, right? The results will be equal. And so now we can, since x is out of the picture, we can now solve this for y to find out what y is equal to. So we'll divide 17 on both sides, and we get y is equal to 1. All right. So just like in the previous problem, we still need to find the x value. So we're going to plug this back into one of the original equations. So I'll try to find the one that looks like it'll be easier to work with, and I think it's going to be the bottom one because it's equal to 0. So 0 is a nice number to work with. So I'll plug it into this bottom equation. We have negative x plus 8y equals 0. I'm plugging in 1 for y. And so we're going to get negative x plus 8 is equal to 0. We'll subtract 8 from both sides. We get negative x is equal to negative 8. Divide by negative 1 on both sides. We get x is equal to 8. And so as an ordered pair, it's going to be 8 comma 1. Unfortunately, they won't all be that easy. So here, if I took the same approach and said, okay, I'm just going to go ahead and add these equations together, don't do this because this doesn't work out, but if you were to try it, here's what would happen. You get 5r plus 3r, which is 8r. You get negative 3s minus 6s, which will be minus 9s. And then on the right-hand side, you get 11 plus negative 6, which would be 5. Right? And while this equation is true, if 5r minus 3s equals 11, and if 3r minus 6s equals negative 6, then it's also true that AR minus 9S would equal 5. So it's a true equation, but I'm no closer to finding my solution. I can't solve this for R. I can't solve it for S because they're in each other's way, right? So what needs to happen with the elimination method is a variable has to get canceled out, so one of them's out of the picture. Then you can solve for the other one. So this, while it's not wrong, is not getting us where we need to go. So what we need to do is do a little bit of work here to make sure a variable cancels out. And so you might think something like, well, if only this was a plus 6s here. If this was a plus 6s, when I add it to the minus 6s, this is getting to be like a tongue twister to say that, then they would have canceled out. But instead of wishing for it to be a 6s, let's make it into a 6s by multiplying the top equation by -2. Right? So now when you multiply, you can't just multiply it to this term, you have to multiply it to everything. So we're going to distribute it. We get -2 times 5r, which will be -10r. We'll get -2 times -3s, which will be plus 6s. So we got what we wanted there. And then we'll get -2 times 11, which will be -22. The bottom equation will just leave the same. 3r minus 6s equals -6. And now when I add these together, I'll get some results. And so adding the r's together, we get -7r. The s's are going to cancel each other out. And then we'll add the right-hand side. We get -22 minus 6, which will be -28. We set these equal to each other. Now we can solve for r since s is out of the picture. Right, so divide by -7 on both sides. And we get that r is equal to 4. Right. Now we need to go back and find s. So you want to plug it back into one of your original equations. This one looks like it's 50-50 as far as like there's one doesn't look any easier than the other. So I think you're okay. Whichever equation you want to use here, it's going to be just as much work either way. So I will plug it into the bottom one because I guess the numbers are a little bit smaller. That's maybe one reason why you'd pick the bottom one. And so I'll plug that in for r here. So I have 3r minus 6s equals -6. We're going to plug in 4 for r. It's supposed to be a 4. Minus 6s equals -6. So we get 12 minus 6s equals -6 minus 12 from both sides. So we get -6s is equal to -18. Divide by -6 on both sides, we get s is equal to 3. Now to put this as an ordered pair, since it's not your usual x and y, you just want to go with alphabetical order. So r goes first. So we'll put r first and then we'll put s. So we get 4, 3. All right. And that's what you would type in the Math Excel as your answer. Okay, let's try another one, elimination method. This is the worst case scenario. So notice what we had to do here was we had to multiply the top equation by -2 in order to guarantee that a variable would cancel out. So we had to alter one equation to make that happen. In this example, we have to alter both equations. So there's nothing I can multiply to the 3y to make it equal -4y. To make it cancel out with the positive 4y, right? Because 3 isn't going to cooperate and help me get 4. And so what we have to do is multiply both of these up to something. Now let's go and erase this here. We have to multiply both of these up to something so that they'll cancel out. We have to multiply them both up to a common number. I guess I should finish my thought there. And so it's like doing a common denominator. So with 3 and 4, what's a common number that we can make both of them equal? 12, right? Just like the common denominator of 3 and 4 would be 12. So I want to make these both equal to 12 so they can cancel each other out. But the other piece of the puzzle is that we also have to make them opposite sign. Because if they're both positive 12, they're not going to cancel out. So we need one positive 12, we need one negative 12. So for the top one, I'll multiply by positive 4, and that'll make this into a positive 12y. And for the bottom equation, I'll multiply that by a -3, and that'll make this into a -12y. And then the y's will cancel each other out. So go ahead and distribute. It has to get multiplied to everything. So we'll get 4 times 4x, which is 16x. We'll get 4 times 3y, which is the 12y that we wanted there. And then we're going to get equals 4 times 48, which I don't have a calculator handy with me here. So let me think about what that would be. 96, 48 times 2 would be 96, and then I need to times 2 again. So that's going to be 99 be 180, so it's going to be 192, I hope. I guess we'll find out as we work through this. We'll see how things work out. Do the same thing on the bottom, right? We get -3 times 3x, which is -9x. Negative 3 times 4y is negative 12y, so we can make sure the y's are going to cancel out, equals negative 3 times 50 would be negative 150. So thankfully that one worked out a little bit easier. Now we'll go ahead and add these two equations together. Add the left-hand sides, add the right-hand sides. 16x minus 9x would be, I don't know why I put a negative there. It's going to be positive 7x. The y's cancel each other out. That's the important thing that we did there to make sure those would cancel out. And on the right-hand side, we add these together, we get 42, which is very promising because this is going to work out nice, right? Divide by 7 on both sides, we get x is equal to 6. So that makes me feel like 192 is probably right. All right, so we get x is equal to 6. Let's plug it back into one of the original equations. So I'm going to plug it back in. I'll just do the bottom one again. It really doesn't matter here. They're both going to be equally difficult. Right, and so we're going to plug in 6 for x, and then we'll solve for y to get the corresponding value for y. So we're going to get 18 plus 4y is equal to 50. We'll subtract the 18 from both sides. We get 4y is equal to, I feel like I'm tired, I can't do math right now, 32. Divide by 4 on both sides, we get y is equal to 8. All right, so we get 6 comma 8. We put it as an ordered pair. All right, so that's elimination method. We might have one more that works out in an unusual way, but I think this one will be easier to get at the answer. So here, the numbers already match up. The only thing that doesn't match up or I guess we don't want them to match up, but the only thing that we need to do something about is to get them to be opposite sign, right? They're already the same number. I just need one to be positive, one to be negative. So I'll do that with the top one. I'll multiply it by -1 to change the sign of this so that it'll be positive 15y, so it'll cancel out with the negative 15y. So let's multiply -1 to everything up here. I'll get negative 5x, I'll get plus 15y, and I'll get -2 on the right-hand side. For the bottom equation, we're just going to leave it the way it is. And I don't know why it's not writing here. Let's try that again. 3, and this will be x right here. All right. So we leave the bottom equation the way it already was, and now we'll add these together, and maybe you've already seen this coming a mile away, but not only do the y's cancel out like we were working towards, but the x's also cancel each other out. And that's not something I was trying to make happen, but it ends up happening anyways. So they both cancel out, and so since there's nothing left over here, we need to put a 0. Right, equals, add these together, you get 1. So I thought this would work out to be true, but I guess I didn't put that kind of problem on this practice test. And so, and maybe you won't have one on the test that you take. So it could be a case of it might give you either one. So you need to be ready for both. So this time it was false. So just like the last example where this happened, that means there's no solution. So if your variables completely disappear on you and you get something that's false, there's no solution to that system of equations. Just to cover my bases here, if we got something like, let's not use 0, if we got something like 1 equals 1, well, that would be true. And so in that case, it would be infinite solutions. And either that'll be an option. You'll have one option that says no solution. The other option will say infinite solutions. Or the other possibility is it might want you to be a little more specific than that. So just in case it asks you to be more specific, so I'm assuming that's all it's going to ask you. And you're just going to say there's an infinite number of solutions. The thing you got to be careful about is it doesn't mean anything works. So we tend to think infinite means anything you want will be a solution. That's not the case here. So for example, 0, 0 would not be a solution to either one of these, right? If I plugged in zeros here, I'd get 0 equals 2. That doesn't work. If I plugged in zeros here, I'd get 0 equals 3. That doesn't work. And so it doesn't mean any ordered pair would be a solution to the system. So what you would have to do is still specify that it has to satisfy one of the equations in the system. So the way you would set it up is like this. And again, this is just in case it asks you to do this. I can't remember if it does or not. Because in some classes I teach it does, in some classes it doesn't. So you put the set of all ordered pairs x comma y such that, and then Math Excel have a box for you to type in something, and what you would type in is one of the equations. It doesn't matter which one. So you just put one of your equations here. Sorry, I keep erasing. Just put one of the equations here in this box. And so I could take the top one, for example, and type in 5x minus 15y equals 2. So you type that in there, and that's how you would describe it's an infinite number of solutions. There's an infinite number of ways of satisfying this equation. So it's still infinite, but it still has some restrictions. You can't just let the ordered pairs be whatever they want. I don't know why I said ordered pairs. I meant to say ordered pairs, so I'm sorry I said that funny. All right, so the ordered pairs can't be whatever you want. They still have to satisfy one of the equations in the system, and so that's what you would be saying by doing this. So, all right, let's take a look at the next example. All right. So here we're coming to these word problems, so these might take a little bit more time. A student makes a $9.25 purchase at the bookstore with a $20 bill. Sorry, I take a coffee break there. The store has no bills and gives the change in quarters and 50-cent pieces. There are 30 coins in all. How many of each kind are there? So this is a very classic system of equations word problem, meaning the word problem is best solved using a system of equations. That comes about because there are two unknown values, right? There's the number of quarters that we don't know, so we could call that, I don't know, Q for quarters, and there's a number of 50-cent pieces, which we don't know how many of those there are either, so we'll call that F for 50-cent pieces. And so keep in mind that this is representing the number of quarters, and this is supposed to be a pound sign here, the number of quarters and the number of 50-cent pieces is what these variables represent. Since there's 30 coins in all, I get one equation from that the number of quarters plus the number of 50-cent pieces has to equal 30 because there's 30 coins altogether. Something I kind of should have mentioned a moment ago is if you have two variables, you need to have two equations in order to get a solution. So this will be one of my equations. The other equation is going to come from the value of those coins. There was a $9.25 purchase paid for with a $20 bill. So the change, we're talking about the change here, is going to be the $20 that was paid minus the bill, which is $9.25. And that means the person should be getting back in change $10.75 in quarters and 50-cent pieces. Now, I will sometimes have students on the test that they think of it like this. They'll say, well, quarters plus 50-cent pieces has to add up to $10.75. But if you set up your equation like this, you're being too vague about what Q and F are representing. Q is the number of quarters. And so you don't want to take the number of quarters plus the number of 50-cent pieces. That doesn't add up to the value. What you need to do here is multiply the number of quarters you have by the value of each quarter, which is 25 cents. So each quarter is worth 25 cents. And together that gives me the value of the quarters plus the value of the 50-cent pieces. You want to take the number of 50-cent pieces you have times the value of each one, which is 50 cents, 0.5. And this together gives you the value of the 50-cent pieces. And the total value of those two together is $10.75. So those are the two equations. And now you need to solve this system of equations. You can either do the elimination method. It's kind of set up for that to work. Or you could do substitution, which I think is easier here because it's not that hard to solve this top equation for Q or for F. And so I'm just going to go ahead and solve the top equation for Q. It doesn't matter which one. I'll solve it for Q by subtracting F to the other side. And so I'm going to write it over here. Q equals 30 minus F. And then now that I have that top equation solved for Q, I can plug that into the bottom equation. Sorry, I keep hitting the eraser button on my pen. All right. And so in place of Q, we're going to plug in 30 minus F. Put parentheses around that. Everything else in this equation stays the same. So we get 0.25 times Q plus 0.50 times F equals $10.75. And then I solve this equation for F. So we'll distribute the 0.25. Probably could have used a calculator here as well. So let me think about this. So this would be 750, I think. So if you had 30 quarters, right? How much money would you have if you had 30 quarters? I think you'd have $7.50. No, that might be too little. Let me think about that. So $4 make a quarter. Yeah, I think that's right. Yeah, it's gonna be $7.50. Okay, minus 0.25 F, right? Because you're gonna multiply to that as well, plus the 0.50 F equals the $10.75. And I'm going to do a couple things at once here. I'm going to go ahead and combine these together. And while I'm at it, I'll go ahead and subtract the 750 to the other side, because I know ultimately that's what I'm going to want to do with that. So combining these together, we get 0.25f equals 1075 minus 750. That's going to be 325. So then we'll divide by 0.25 on both sides, and we'll find f. Now, there's some restrictions here to the kind of answer we can get. F cannot be a fraction. It can't be a decimal, right? F is the number of 50-cent pieces. You can't have 3.5 50-cent pieces, right? It's either going to be 3 or it's going to be 4. So this has to work out as a whole number or something's wrong. So what do we get here? 25 goes into 325. Let's see, 4, be 12, 13. I think it'll be 13. All right, so we're going to get 13 here. So there's 13 50-cent pieces. We still want to find the number of quarters, so we'll plug that back into one of the original equations. I think this would be the easier one to figure out Q from. And so we'll get Q is equal to 30 minus 13. So the number of quarters would be 17. All right, so 17 quarters, 13 50-cent pieces. That's 30 coins altogether. And if you work out the value of it, if you have 17 quarters and 13 50-cent pieces, it should add up to $10.75. Make sure you type the correct one into the correct box. So the first one it asks for is the number of quarters. And so you want to make sure you type that into the first box. So Q is 17. So we'll put 17 in the first box, 13 in the second box. Okay, let's take a look at this next word problem. We have one canned juice drink is 25% orange juice. Another is 5% orange juice. How many liters of each should be mixed together in order to get 20 liters, that is 18% orange juice? Okay, so this is a mixture problem, and it's specifically, there's two kinds of mixture problems that you'll typically encounter. This is specifically a percent mixture problem. So the formula that works here is, and Math Excel may not provide formulas, so as you're going through the homework and looking at the examples on Math Excel, they might have a little bit of a different approach to this, but I like just using a formula. Q is, let's start with this side. A is the amount of the canned juice drink. R is the percent of orange juice in that canned juice drink. And if you multiply the percent times the total amount, what you get from that is the amount of the quantity. Q stands for quantity, which is the quantity of orange juice in the canned juice drink. All right, so you're going to find how many ounces of orange juice is mixed in with the however many ounces of the canned juice drink that you have altogether. So I know it's confusing because they're both called juice, but Q is specifically the amount of orange juice, whereas A is just the total amount of juice altogether. All right, so I hope that made sense. This applies to three different things in this problem. This is what makes this problem difficult. It applies to the first juice drink, which is 25% orange juice. It applies to the second one, which is 5% orange juice, and it applies to the two being mixed together. So this formula applies to all three of these percentages here. So to organize all that information, we're going to set up a table. I'm going to try to set up a table. All right. And we're going to make a row for each thing that the formula applies to. So this is a very common strategy for this kind of word problem. And so we'll have the first juice drink, the second juice drink, and the mixture of the two that we're trying to create. That's what each row stands for. We're going to make columns for each variable in our formula. So we'll make a column for A, we'll make a column for R, and we're going to make a column for Q. Then we go back through and read the problem, picking out the information that's available, placing it on the table. The first drink is 25% orange juice, so that's our percent for the first drink, or for the first canned drink. Yeah, I think that's the right thing to call it. Sorry, drink. 5% for the second drink, right? It's 5% orange juice. And then for the mixture of the two, we want the drink to be 18%. We also know that the amount we want for the mixture of the two is to be 20 liters. All right, so we can go ahead and plug that into our table. So any box that's left empty is an unknown value. You typically want to keep the last column clear, because what you're going to end up doing is using the formula to fill in this last column. A times R is equal to Q. So you take the A from this row, times the R from this row, multiply those together, and that's how you fill in the box for Q. We could actually go ahead and do that here with the last row because we have all the information. We have 20 times 0.18. And again, I could really use a calculator on this. I think it's going to be 3.6. Right, so you get 3.6 there when you multiply those together. And just, again, to help you understand how this formula works, this drink is 20 liters altogether. 18% of that 20 liters is orange juice. And so that equates to 3.6 liters of orange juice. So out of the 20-liter drink, 3.6 of those liters is orange juice, and there's 16.4 liters of other stuff, of other kind of juice in there, right? We need something here in these first two boxes before we can apply the formula to fill in this last column. So this is where we're going to start using variables. And I was going to do it a little bit of a different way, but we might as well use system of equations here. So I'll let the first amount be x. I'll let the second amount be y. Right? Just use different letters here because they're two different unknown values. Apply the formula. So the same thing we did down here, we're going to take a times r, and whatever we get, we're going to write that in the box for q. So we'll get x times 0.25. That's going to give me 0.25x. And we'll get y times 0.05, which is going to be 0.05y. Now that we have the table completely filled in, what we need to extract out of this table, since we have two variables, we need two equations. One of the equations that you're going to get, it always happens this way with mixture problems. This is the quantity of orange juice from the first drink. This is the quantity of orange juice from the second drink. This is the quantity of orange juice of the two mixed together. So the relationship here is that if you take the amount of orange juice from the first drink and add it to the amount of orange juice from the second drink, it should add up to the total of the orange juice in the two drinks mixed together, right? So this is like the total. This is the amount from the first drink. This is the amount from the second drink. This is the total amount. So that's one equation, 0.25x plus 0.05y equals 3.6. The second equation you're going to get from the first column for the same reason. You're taking x liters of the first drink, you're mixing it with y liters of the second drink, and your total is going to be 20 liters altogether. So if you take the amount of the first drink plus the amount of the second drink, it has to add up to the total amount, which is 20 liters altogether. So we're going to get x plus y equals 20. There's my two equations. So I solve this as a system of equations. I think substitution is the easiest way to do this. And again, it doesn't matter which one we solve for. So I'm going to solve this one for y. I'll subtract x to the other side, and I'm going to write it up here. I'm going to get y equals 20 minus x. I'm going to plug that in to my other equation. And so I'll get 0.25x. Just to save myself some space, I'm not going to rewrite this equation again. In place of y, I'm going to plug in the 20 minus x. So I get 0.05 still. In place of y, we're going to have 20 minus x. And then the rest of it stays the same. We get equals 3.6. So I solve this equation for x. So I will distribute the 0.05. I'll get, so this is going to be, it's kind of a weird answer, but you're going to get 1 plus, not plus, why did I put plus? Let's undo that. Minus 0.05x. And this will still be here, 0.25x. So we'll copy that down. And it's still equal to 3.6. So I'm going to combine like terms. And so we will have this combined with this. So it's going to give me 0.20x. And while I'm at it, I might as well subtract the 1 to the other side. So I'll go ahead and do that. And I'll get this equals 2.6. Right, so these got combined together to give me the 0.20x. The 1 got moved to the other side, and that's how I got 2.6. Now I will divide by 0.20. And this doesn't have to work out as a nice answer, right? You can have 3.5 liters or something, right? You can have 3.1278 liters or something. But usually it works out to be a nice answer. So if you get something that's a little bit off, you might want to double check because normally it works out nice. So what are we going to get here? We're going to get like 26 divided by 2, which will be 13. So you're going to get, you do get a nice answer here. You get 13 for x. That's how much of the 25% concentration we want to use. We need to find how much of the 5% concentration we want to use. So we're going to plug that back into one of the original equations. I'm going to suggest plugging it back into this one right here where it's already solved for y. So we're going to get y equals 20 minus 13, which gives me 7. Right? And so y is the amount of the 5% concentration. So you want to make sure you're typing the right number into the right box. For the 25% one, it's x, which is 13. So I'll put 13 here. For the 5% one, it's y, which is 7. Okay, one more word problem. And then we have a system of inequalities, but there's only a couple of those. So we're almost done. Again, I'm trying to keep these videos under 50 minutes. I just hit the 50-minute mark. I might do some editing, so it might be a little bit less than that by the time you're listening to this. But hopefully we'll keep it under an hour like the last one. So Alvin paddled for 3 hours with a 4 km/h current to reach a campsite. The return trip against the same current took 7 hours. Find the speed of the boat in still water. So whenever you have a word problem that involves time and a speed, it doesn't really refer to distance here, but it's a relevant part of the situation as well. The formula that you want to use here is D equals RT. And for these kind of problems where there's a distance and a time and a speed, drawing a picture is often very helpful. So what I would recommend doing is let's draw a picture of, let's imagine it's a river. It doesn't really say it's a river, but let's imagine it's a river. Right, so here's our river. And this river has a current. It's going this way, let's say. So the water is flowing in this direction. And Alvin has his boat in the water. It's just going to be a rectangle, right? And so if he paddles with the current, going in the direction of the current, the trip takes him 3 hours. I don't know why I was going to put 4. It takes 3 hours, right? Going in that direction. This current is a 4 km/h. You can think of it as miles per hour. It doesn't really matter what the units are, but the current is 4 km/h. Right, so he's getting a boost. So however fast he's able to paddle the boat, he's going to get to go an extra 4 km/h faster than that because the current's going to push him along that much faster. Right? Going against the current, so let's imagine the opposite direction. So here's his boat coming back against the current. He's slowed down by the current by 4 km/h. So he's going to, however fast he paddles, he's going to go 4 km/h slower because the water's pushing against him. And in this situation, it takes him 7 hours to make the same trip. All right, so 7 hours. All right. So we have this one formula, but it applies to both of these scenarios here. And so since it's one formula that applies to more than one thing, I'm going to use a table to organize this information. This time we only need 2 rows, one going with the current and one going against the current. Right, there's only 2 things the formula applies to. We want to make a column for each variable in the formula, so I'll make a column for R. I don't know why I put R twice. A column for T and a column for D. Right? And that way our formula is built into the table. And we're going to try to fill in the first 2 columns, let the formula fill in the last column for us, and then from the last column we'll figure out what our equation is. The one thing we don't know in this problem is how fast the boat goes in still water, which is the thing that we're looking for. And so I'm going to call that x. So I'm going to imagine that Alvin's able to paddle this boat at x km/h. When he's going with the current, he's going to get to go an extra 4 km/h faster than that. So however fast he could paddle the boat on his own, which is x, plus 4 km/h, because he's going to get to go extra fast with the current. Going against the current, it's however fast he can paddle the boat minus the 4 km/h, because he's going to get pushed back and slowed down by that current. The time, we're told, going with the current is 3 hours. The time against the current is 7 hours. Right? And so this time we don't need a system of equations because we were able to set this up with just one variable. So all we need is just one equation to find the answer. And we're going to get that equation by looking at the distances here. So to get the distance, we're going to use the formula, multiply r times t, do that for each row. So r here is x plus 4 times t, which is 3. And so we'll get 3 times x plus 4 here for the distance with the current. The distance against the current is going to be 7 times x minus 4. And then we want to make an equation out of these 2 things. Now, in a lot of word problems, you end up adding the last column together and setting it equal to something. But with distance problems, they can do different things. You might subtract them. You might set them equal to each other. So you have to read the problem closely to figure out what you need to do here. The key word in this situation, I don't know if I see it here, Alvin paddled for 3 hours to reach a campsite. I guess the key word here would be the return trip. the fact that it's a return trip means it's the same trip. He's taking the same trip in reverse, which means the distances will be the same, right? So the distance there will be the same as the distance back because that's what a return trip means, right? And so the distances here are going to be equal to each other. So we get 3 times x plus 4. That distance should equal this distance, 7 times x minus 4. So we set them equal to each other, solve for x to find the speed of the boat in still water. How fast Alvin can paddle that boat on his own. We distribute the 3, we distribute the 7, so we get 3x plus 12 equals 7x minus 28. And so we need to get x on one side, so I'll go ahead and subtract the 7x, get it on the left-hand side. Since I'm getting x over here, I don't want the 12 to stick around, so I'll go ahead and subtract 12 to the right-hand side. And we get negative 4x equals negative 40. So we divide by negative 4 on both sides. I don't know if I can fit that here in the window that I have. Let's see, okay, barely. And so we end up getting x is equal to 10. And so that's how fast Alvin's paddling the boat. He paddles the boat 10 miles per hour. When he's going with the current, his net speed is 14, right? Because he's going to get the extra boost. When he's going against the current, his net speed is 6 because he's working against the current. But what we're being asked for is the speed of the boat in still water, which is just going to be 10. All right. Let's take a look at these last two examples. Graph this inequality. And so this inequality has two variables. So to graph the solution set to this, we're going to have to use a Cartesian coordinate system, which has two axes. There's a couple ways you can go about doing this. The way that I prefer, and MathXL might have a different explanation, but what I like to do is solve this for y. That's what I do first. I'm going to subtract 5x from both sides. And so we'll get 6y is less than or equal to 30 minus 5x. And then I divide by 6 on both sides. So I'll get y is less than or equal to, the 6 divides into both of these, so I'll get 30 divided by 6, which is 5, minus 5 over 6x, which we can write as 5 6x. All right, so this is my inequality, solve for y. That's the first step. The second step is to graph this as if it were an equation. So I'm going to graph y equals 5 minus 5 6x. So this goes back to the beginning of the video. We're graphing a line. And so we need the y-intercept, which is 0, 5, which, oh, this kind of stinks. No, be careful about this when you're doing your homework or doing the test. Notice the scale here. These marks are going by 2s. This is 2, 4, 6, 8, 10. So 0, 5, unfortunately, is going to be halfway in between 4 and 6. So don't I get a lot of students, they see the 4, and so they just put it right above it on the next line above it. But the next line above it is 6 in this case. So we got to split the difference, and the y-intercept will be at 5, which is halfway between 4 and 6. And then the slope is negative 5/6, which means we're going to go down 5 and to the right 6. All right, so from this point, we're going to go down 5, which gets us back down to the x-axis, and then to the right 6, which will be this point right here. So again, going by 2s, that's 4, this one's 6. And so I get those 2 points. Now when I go to graph this line, I have to make a choice before I actually draw it in, and I have to decide whether the line should be a solid line or a dashed line. This is analogous to the inequalities we did before, deciding whether we should use a parentheses or a bracket in the graph. We're using a dashed line like a parentheses to show we're not including the line in our solution set. We use a solid line as like a bracket to show that we are including the line in our solution set. So the rule comes down to, if there's an equals to, I guess let me talk about it here. Let me try that again. If there's an equals to, it's going to be a solid line when you graph it. So when you graph over here, make it a solid line. If there is no equals to, you need to make it a dashed line. And I think MathXL is kind of picky about when you make that choice. I think you have to decide that before you even plot the points. So I kind of waited to the last possible second for me, but on MathXL, I think you should decide this ahead of time. So you pick the line graphing tool, and then it gives you a toggle. Do you want a solid line or a dashed line? And you want to make sure you make that selection first. Make it a solid line, then plot the points. And so we're going to connect these 2 points with a straight line, and it's going to be a solid line. Right? And this is going to be the border to my solution set. So whatever line you end up graphing here, that's the border to your solution set. And let me try to see, I'm kind of stalling here because I just don't think I'm going to do a good job graphing this. Let me try here. Okay, so connect those 2 points with a straight line. Yeah, not the best job. Oh, that was terrible, but you guys get the idea. Then to decide, so that's the line, that's where it's equal to, but I also need to find all the ordered pairs where y is less than 5 minus 5, 6x. Right, so on the line is where y equals 5 minus 5, 6x. I'm trying to find also, in addition to that, all the points where y is less than that. So I always ask my students, in what direction would you have to move from this line to find y coordinates that are smaller, that are less than the ones that are on this line? And the correct answer is you would move down, right? If you go down, the y coordinates get smaller. If you go up, the y coordinates get bigger. So whenever you have y is less than, and this trick only works if you have it solved for y. You can't really make that judgment up here. You have to solve it for y first, and then if you have y is less than, you want to shade below the graph. So we're going to shade below. And so this is step 3. Decide whether you should shade above or below. If it's less than, you shade below. If it's greater than, you shade above. Right? And so we're going to shade below this line. All the points below this line here, all these points here, will satisfy this inequality. Every point here, the y coordinate will be less than 5 minus 5, 6x. All right, so there's an infinite number of solutions, and this is where you find them all. All right, so that's how you solve an inequality with, it's just one inequality. You're also going to have some problems in chapter 3 where you have to solve a system of inequalities. So they give you more than one. But you kind of do it in the same way. You're going to solve both of these for y. You're going to graph both of them on the same Cartesian coordinate system, and then you're going to shade in the appropriate region that satisfies both of them. All right, so we'll solve the first one for y. So let's go ahead and do the first one here. We'll subtract x from both sides. We get that y is less than or equal to 9 minus x. So that was pretty easy. We're done. All right. And then we'll solve the second one for y. We get x minus y is less than or equal to 10. Probably should use a different color there. So I'll switch now. Subtract x from both sides just like we did before, but this one has an extra twist to it. We have to get y by itself by dividing -1 on both sides. So we'll get y on the left-hand side. The -1 divides into both of these, so we get 10 over -1, which is -10, and then negative x over -1, which will be positive x. And the twist here is that if you divide by a negative, just like you did before with inequalities, you have to flip the symbol the other way. So this becomes a greater than or equal to. So that's solving the second one for y. Sorry. All right. The second step is to graph these as if they were equations. So we're going to graph y equals 9 minus x, and we're going to graph y equals -10 plus x. We're going to graph both of them. And if you'll allow me to do this, I guess you don't have a choice since I'm, the one doing the video here, and you don't have a chance to give me the input. But I'm just gonna verbally go through the process of graphing this without writing out all the details. So again, we'll start with the y-intercept, which is 9 for this first one. Now here we are going by ones, right? This is 1, 2, 3, 4. So 9 would be just above 8, which would be right here. If I could draw it, if it would let me draw. I don't know why it's not letting me draw here. Maybe I'm pushing the eraser for some reason, somehow. Let's try that again. Okay. No, it's not drawing. What's going on? Okay, now it's... Well, that's really weird. Like, I don't know why it's not letting me draw up here. I didn't have that problem before. I'm not sure what to do except maybe set up my own graph. So maybe I'm going to have to do that. So I apologize. It's not letting me draw on the image I have here. And I'm not sure why it's doing that. Let's see. My fear is that maybe, because it looks like it's drawing behind it. So somehow this ended up on top instead of being at the back. But I don't know how to shuffle it to the back again. So I'm looking for buttons up here that might do that, but I don't see anything that will allow me to do that. Let's see what this does. No, that doesn't look like it does anything. Maybe it's this. No, that's just pages here. Okay. Well, let me just make a new page. I think I can do that somehow. Oh man, I can't believe I'm just getting stuck on this last problem. We're almost done. Oh yeah, here it is, new page. All right. Sorry, still learning the system here. All right, so I'm just going to make my own graph here, my own Cartesian coordinate system. All right, and this is y and this is x. And so hopefully I gave myself enough room here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 right there. So that's where my first graph was going to start at 0, 9. And then the slope, if we go back, the slope is going to be -1. So we're going to go down 1 and to the right 1. Right. So down 1 to the right 1. Let me mark the 1 down here. All right. So down 1 to the right 1 would be right here. And then we'll connect those 2 points with a straight line. And we have to decide, should it be a solid line or a dashed line? We go back and look, and this inequality has an equals to. So this one, again, is solid. Unfortunately, my examples didn't have any dashed lines. So hopefully you just have to do as I say, not as I do. So if there is no equals to, make sure it's a dashed line. So we're going to connect these with a solid line. So it's going to look something like this and go this way like this. All right. For the second equation, we're going to graph on here. The y-intercept is -10. I thought it was +10. So -10, so I have to go down the other way. 10. I think we have enough room to do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's -10 right there. And the slope is +1, if I'm not mistaken. All right, +1 there. And so we're going to go up 1 to the right 1. So starting from -10, up 1 to the right 1 would be right there. And I'm going to have to extend this line a little bit. Excuse me, a little bit further. And so it's going to look like this. Right. And it's going to be a solid line also because we have the equals to right here. So we make it a solid line as well. Then to decide which region to shade in, we do the same thing we did on the last example, except we have to make sure we are meeting both criteria here, both requirements. So for this first one, for the first line, we want to shade below because it's y is less than, we want to shade below that line. And this one, because y is greater than, we want to shade above that line. So we have to do both of these things. We want to shade below the first line, but above the second line. Sorry, I kept erasing. Let me try that again. Oh gosh, what did I do? Let's undo that. Okay, let's try this. Yeah, I didn't want to erase the whole thing, just this part right here. Okay. Sorry, this has become kind of a disaster here. So we'll shade above the second line, below the first line, above the second line. And so let's go back to the graph that we have. So this was my first line here. I want to shade below the first line, but above the second line. So it would be this region right here that meets both criteria. Let me use a different color. All right, so it's going to be this region right here. All right. Why is it doing that? Okay. All right. Sorry, I keep saying that. So that would be my solution set. The other thing it's asking for is the point of intersection, which is called the vertex. Where are these two lines crossing each other? And if you're doing this on Math Excel, you may be able to kind of just find it out by inspection. You can just look closely and see where the two lines are going to cross each other. But since I'm doing this by hand, it's going to be a little bit inaccurate. So another way you can find the point of intersection is by solving the inequalities as a system of equations. So just really quick, this won't take too long. Solve this as if they were equations. You have x plus y is equal to 9. You have x minus y is equal to 10. Solve this as a system of equations, and it will tell you where the two lines cross each other. And it's already set up for elimination method, right? All we have to do is add these two equations together. The y's cancel out. We get 2x is equal to 19. Divide by 2 on both sides. And so now it's writing on top. You see that? That was really weird. So I accidentally erased it and I put it back and now it's working the right way. All right, technology, right? So we get x is equal to 19 over 2. And then we need to find the y coordinate that goes with that. So we'll plug it back in. I don't want to deal with that negative sign, so I'm going to plug it back into the top one here. And I'm just going to work it out over here. So we'll plug in 19 over 2 for x. And then we'll solve for y. So we'll subtract 19 over 2 from both sides. And we'll get y is equal to 9 minus 19 over 2. We need a common denominator, which is 2. Multiply that to the top and bottom. And so we're going to get 18 over 2 minus 19 over 2, which is going to be -1/2. So that'd be our That'd be our y coordinate there. So we'll get y is equal to negative 1/2. So the vertex where they intersect each other, and this is where you want to type it in, is going to be at 19 over 2. I'm just laughing because this screen looks like a big mess. I'm really sorry. I hope when you're watching it that you're able to kind of follow along with the steps, even though I made a big mess out of everything here. So this vertex, this is the vertex. This is where the two lines cross. That's what you want to type in there. All right. So if you have any questions, please contact me, send me an email, set up a time to meet with me or with a tutor on campus. I'd be happy to answer any questions that you have about Chapter 3. Good luck with this chapter, and let me know if there's anything else I can do to help.